Hi there, my name's Lisa Franey, Vice President of Sales and Marketing for Risco Incorporated. This is my husband, Joe Franey, President of Risco. Risco Incorporated was founded in 1964 and is currently a second-generation family business. We're a cold heading manufacturer located in beautiful Beaumont, California. We do cold heading, secondary operations such as thread roll, slotting, some deburring, and some polish. Per customer print is how we take
our orders. Everything is to print. We don't make anything that's we hope to sell. Everything's per order. We work off of our customers' prints. We don't do any engineering here, but we do assist in engineering when they're coming, trying to develop a new part or a new thing. Our biggest industries that we serve are irrigation companies. We do aerospace stuff, solid aluminum rivets. We do aftermarket automotive work.
Ag market. We do a lot for the agricultural market. Military
stuff, stuff that goes into military helmets.
And then various industries after that. We do solid rivets, some semi-tubular rivets. We do socket cap screws. Anything I left out on that?
No, it's pretty much everything. Guitar screws, all sorts of crazy odds and ends. Nothing that's a standard, all specialty stuff. All, like I said, customer specifications.
And everything's cold-headed?
Everything is cold-headed. I'm sure you guys have learned the basics of cold heading, but cold heading is, a lot of people think we are like screw machines. Cold heading is actually a completely different process. It's used for mass production. So our machines on average produce about 50,000 pieces a day. It's also a stronger product because the material comes in a wire coil and it's actually formed inside of a die. The material is never cut, which can compromise the grain structure and strength. So yeah, mass quantity. Usually our screw orders will be for about 50,000 pieces, up to
or more.
Yeah, the basic for cold header is usually about 50,000 pieces. So we're going to take you guys on a tour of the shop. It's probably going to be loud in certain areas, but we'll do the best we can to show you this virtual tour. Once the contract's received, it goes through contract review, assembled in a packet with the print, work instructions, etc. Since we are an ISO certified company, we do need to follow those procedures. But then we actually make a job tag, looks like this, and it's then given to the production manager, or Joe, to actually schedule the machines. The job tag will show the part number, the customer, the PO, the due date, and he'll then put it on whatever machine is going to produce that part the best. Each operator receives a traveler, which has the processes that this part is going to go through. This is where they're going to know what material they're manufacturing with, and they are required to sign off after every procedure. The back is where the requirements for the dimensions are, and they will have to also complete that. Each packet also has a print so that the operator can verify the print as well as the required dimensions.
So once everything comes into this hallway, it's set up on the machines. The operators know what they're going to run. They can look at the tag, they'll grab their traveler, they'll grab their tooling, they'll take it out on the floor, start running. This is so they don't have to have somebody come in and telling them, okay, this is the next job, that's the next job. It's all right here. Any changes that are made get made ahead of time. We try to stick to our orders for our due dates, make sure everything makes it out in a timely manner.
So do you start on the top or do you start on the bottom?
We start at the top. The top job is the job that's on the machine. It's either currently running or being set up at this particular time. The cool thing about the tags is it helps with, it gives you the quantity of parts. so that you can help do math and figure out around what days it needs to come up. If we need to give an update to a customer, yeah, you know, your job's going to be on in another 2 or 3 weeks, and then we'll have it off in this X amount of time. It helps us, not only the operators, but it helps sales respond to our customers as
give
to
updates as needed.
Give updates as needed. Correct.
Now I know this is a lot of information for everyone, but just so you can kind of visualize this, each one of these whiteboards is broken up into 5 different machines for scheduling purposes. So we have a total of 26 cold headers out there, and this is where the planning starts of what machine they're going to start on. So we're now going to take you out to the shop floor. This is where it's going to get loud. Here we go. House tool room. A lot of the tooling we actually manufacture here.
Okay, so once we've received the contract and it's made its way up on the board and we know when jobs are going to come up, that's when we start scheduling tooling. A lot of the jobs we do are repeat stuff, so we have a stock of tooling that we can pull from, but newer jobs, new R&D jobs, or jobs that we do in high quantities has backup tooling. You have to replace dies after time, you have to replace upsets, hammers, cutters and quills, all the stuff that takes for the machine to run and manufacture the parts. So as you can see, we have a pretty wide variety of sizes and stuff that we do. This is
what sizes do we do, Joe? What diameter?
We can do as small as 0.62 diameter wire, which is like a number 2 diameter rivet, all the way up into, we're doing some 1/2 inch and some 9/16, depending a little bit. 9/16 is pushing our limits just by a little bit. But to show you the different sizes, this is the size die you would use for like an 0.62 rivet, 0.93 diameter rivet, and then this is a die that you would use for a 1/2 inch bolt. So it's 2 entirely different machines, but all the machines are interchangeable with different tooling, can make different sizes within a certain amount of limit. The majority of everything that we make is cut over here on our lathes. We cut die cases, we cut our own upsets, our own hammer cases, cutters, quills, all that stuff is made in-house. We don't make our own punches here, we order that out. We don't make our own thread roll dies or saw blades, but all that stuff at one point or another comes in here for repair, resharpening, cutting down of dies, remaking all sorts of stuff. So this, without this department, the entire shop is in trouble. There's a lot, everything pretty much has to come through here.
Now, we previously touched on it a little bit, but when you say the die, this is where the wire's actually going in and forming the part, correct?
Correct.
And some of the machines have 2 dies, some have 1.
The majority of what we do is 1 die 2 blow machine, a single die. It takes 2 blows, starts with an upset, and gets finished off with a hammer that puts, or a punch that puts the Phillips struck or the hex engagement. And then the other things, the other machines we have are like 2 die 3 blows, where you need a more intricate part, a part that takes a little bit like a power extrusion or different dimensions, different body, like a small thread and then a bigger shoulder on top of it. That takes multi-die work. We have a handful of those machinery too. See, we got another board. Everything we do, we schedule. When guys make requests, they put what they want up here, their name, and the smiley face means it's gotten done. So a lot's gotten done today, apparently. So let's go ahead, head out on the floor. It's about to get loud.
Starting from a coil of wire. We have to order the wire, and when it's received, we actually have to ID that per our ISO system. So you'll see all of the wire here has an ID tag with the number assigned of what it is. It's ID with the type of material and our acceptance lot number so that can be traced throughout the entire process.
So after that happens, everything gets sent off to machine. The majority of the machines that we have in here are a Japanese-built Nakashimada machine. A lot of 1-die 2 blows, like I said earlier, a handful of 2-die 3 blows. Everything we do out here, like I said, it's a constant flow. There's a lot of parts going out. Our key stuff is high quantity. So this machine right here, which helps supply the irrigation industry, we make a pretty cool little part right here. I don't know if you can see that. It's got multiple diameters to it. It's got a Phillips engagement.
So that's part of the product, but this is the process on the machine to get to that. So Joe, what's that?
So this is the, can you see that? This is a cutoff. You take the coil and you get a cutoff of the material. Then in the first blow, you start the form. There's an extrusion point at the bottom, and then at the second blow, it creates the washer and the Phillips head. And then it gets ejected out of the die and the next part comes over.
I'm glad we had these samples because we're actually going to follow this part throughout the entire shop and every process that it goes through.
Okay, so this thing is running relatively fast, but you can see that this piece right here is cutting the wire off. These transfer fingers transfer it over, and then you get pushed into the die. First blow, ground comes up. Second blow, the part ejects out. The next one comes over, and you can see the pan is down here filling up really quick. So as you can see, all the machines that were on the board are all lined out here. There's different sizes, some 4mm machines over here, a lot of our 6 diameter and larger over here. You can see, very similar machine, a lot longer part. There's a lot of adjustment there. This will also get threads put on the end and a point cut under the tip. Now, as we always say, we're a cold heading shop, and we don't hot head. We do some warm heading. So we've got induction heaters that help heat the wire up just a little bit, just so it helps with the formability. But it's not hot heading. So that is totally different. So come down here. Both of these machines are good examples, and we're doing what they call wire drawing. So the wire goes into this machine and it draws it down to a very specific size, usually for precision parts, stuff that we need no fluctuation on the diameter, or we're using one size wire to manufacture multiple product lines, so we can buy the raw material in bulk. This machine right here is also, it's a very long part, and any fluctuation in the wire can cause a lot of fluctuation in the head diameters and the length of the part. So that's why we draw down on this machine. This process of drawing does not shave the wire or cut the wire. It's actually drawing it through a draw die and stretching it out just a little bit so that the wire is completely size. Our variety of range, this machine over here is currently running
these tiny little rivets. Really small.
Now while this machine over here, an old Waterbury number 4, is making some big wheel studs. So you can see the size difference. It's amazing what these machines can do and their capabilities. So that part that we showed you down there that we told you we're going to follow through the entire shop, this is that same part. It's over here waiting for process and to be tumbled so that you can take the oils and deburr a little bit. This part has been through our slotting process, which we'll go through next, and you can see that there's a slot in the bottom of the part.
So as we previously went over,
the traveler's been signed off as it completes each operation.
Back here, this is our tumbling process. These do look like cement mixers, but they are very specifically picked. No, they're just cement mixers. But we use them. We have some of them, or we have like a plastic liner. We have to use the steel ones for other products that need a little bit more abrasive of a tumbler. This is one of the areas that never stops. It's always backed up with parts. It's always busy, and every tumbler's always got something on it.
Can we look inside?
Yeah. So you can see, it's just a cement mixer. These parts spin. The fins in here, like I said, it breaks down the oils. It also takes off any sharp edges. If you slide down here to the steel one, you can see it running right now. Oils and kerosene or solvents that we're using in the process. Those who's waiting to be tumbled had just gone through this process. You got the vibratory bowls up top. They spin around, they go up the ramp. Then they come down this rail, which then flips the part upside down, and with the loading finger loads it into this dial. At which point it goes into this saw box. There's two saw blades inside this box right here, one going clockwise, one going counterclockwise, so that you get a clean cut all the way through. So when it comes out, you get the part with the slot in the bottom. Probably kind of hard to see, but so that you can visualize it, this is the type of saw blade that's inside there. The diameter of the saw blade is set for the size of slot that you want to put in the screw.
So you really do cut it slot. That's the only one that we actually cut.
This is the only process in which we actually cut material away. Well, I take that back. We do trim also, but the majority of what we do, again, is form.
I just heard for years they got to cut the slot.
So the last process of most of these fasteners is when we put the threads on it. Again, it has a very similar hopper or vibratory lead feed. It spins, it goes down the ramp and loads the part in between two dies. You can see here, one of the dies is stationary and the other one reciprocates, and it presses the threads onto a screw. Start off with a screw with no thread, and then it comes out right here with threads on it. No cutting involved here. So that you can get a better visual, why don't you look at Lisa?
So here's the actual thread roll dies. These are just for a basic 1/4 20 thread. One of them is stationary, the other one is moving and pressing the thread on. Both sides have dies, or have threads on there, and they just press on the fastener.
Most of the machines, they run at different speeds. The one we just showed you goes a little slower, it's a very coarse thread. This one's not as intense, and it runs at a very fast speed. You can just see them flying off there. Okay, so that same fastener that we've been following through the whole shop, it was headed, it was slotted, and then it comes to this machine and it gets thread rolled. So again, there's that part, but it has the slot and the threads put on it. It's a plastic application, it goes into a plastic sprinkler, so that's why the thread is so coarse and a little bit different than what most people are accustomed to seeing in threads. Okay, so the last process of almost all our fasteners is to be cleaned and boxed. So that same fastener that we've been following all over the shop comes to this machine. They get dumped into these baskets. Baskets up here on these hot tanks, they have certain solutions inside of them to help get them super clean, take all the oils off. It's a water-based system. These tanks, when activated, start going up and down. It's not going to get going without any weight on it. There you go. So you can see it goes in. As it starts to sink, it'll start gyrating up and down. Gets in there, washes through the whole parts.
Are both sides the same?
Both tanks, this one has a solution inside of it. This side is just a rinse. So once it goes through this side, it rolls over. Tanks come up, rolls over, you start again, you go through the rinse, then it rolls over again, you spray it off a little bit more with some water, then it goes through another centrifuge, spins all the excess water out, and then comes over here, gets loaded into boxes, everything's weighed up with quantities, and then stacked onto pallets. This fastener that we've been showing you all the way through, we're currently having to supply 500,000 of them a week to our customer to keep them happy and keep them satisfied for their current demands. So that keeps us really busy. It takes multiple headers, multiple slaughters, multiple thread rollers to maintain those quantities. And a little bit overtime.
We're in our quality department, a lot quieter in here.
Yeah.
But this is where the operators are coming multiple times a day. They're doing things in here like using the optical comparator to check their dimensions.
Everything also comes through here for first articles, final inspection. Between every operation, operators bring their travelers in here, they bring samples, it's got to be checked, all dimensions are confirmed by the QC, then they get the thumbs up to say, yeah, go ahead and run. And then they have to go through the day, all day, every few minutes, double checking their parts before they dump pans, and then multiple times during the day, like Lisa said, checking stuff on an optical comparator, which projects a very small part a lot bigger and makes it easier to see. You can lay it in there like that. You can take a real tight look at the thread. You can measure the threads, measure the pitch diameters, the minor diameters, major diameters.
Head OD.
And then you can go all the way to the head OD, line it up just right.
This is how you would measure angles, slot depth.
You can check slot depth on this, head heights, everything that needs to be checked, just about can be checked on the optical comparator. Also, the use of micrometers, calipers, depth gauges, all different types of gauges and tools that we use to maintain the integrity of the dimensions of the parts.
And you can see some of that stuff right over here.
So you guys do all of your quality checks here, or do you have to send them out to another lab?
We do. So what we do, it again depends on the customer requirement. So some of our stuff, a lot of the stuff we do for the government does require an independent third-party lab to verify the integrity of the part. So they'll do different processes like mount it, they'll do a lot of pool tests, just to say, hey, another set of eyes was on this and it is what they said it is. So
we do a lot of shear testing also. We have a shear tester over here in this corner. There are some tests that we do have to send out to the lab and other places like that. We have to do, what am I'm drawing a blank here.
what you mean, the lab, right?
Or,
Not a
yeah,
lab?
A lab
The
or
lab.
the lab.
Yeah.
Anyways, micro hardness, stuff like that we don't have equipment in-house to do. We send it out to them, they give us the thumbs up. But as far as dimensionally, we're pretty much self-sustained.
We also have another partner helping maintain that. It's, I don't know if you guys, Beth, do you guys work with AIM?
Yes.
Okay, so AIM also oversees our quality management system and comes in, makes sure that we do what we say we're doing, but we still have to do the groundwork on that. Per our ISO system, we actually have to maintain records and traceability for a minimum of 7 years. This file is dedicated to raw material. So we can go back. It is all also on our server, but we can actually pull hard copies of this one, the acceptance lot number that came in, the type of material, and the size it came in at, because we do take readings of that. We do send stuff out for chemical analysis per ISO. I believe it's every 25th sample goes out to ensure our suppliers are giving us what we ordered. And we also maintain all of our work orders. So, we just cleaned that one out, it looks like. It's all filed by job number. So if we have a customer that wants to see, hey, when you measured this, what were you guys getting? We can actually come in and pull the inspection record and see what we measured in first article inspection as well as final. And like I said, we do have an archive room that has up to 7 years.
But everything goes on the server, you say
Everything's on the server.
Forever.
Correct. Yeah, a lot of our stuff we just haven't gotten around to shredding, so that's why it's still in the archives. So, what else? Oh, Mike is in our quality department. He takes care of doing all the in-house calibration. And I think that's pretty much it right now.
Yeah.
Who's that playing the guitar on the computer?
I have no idea. Maybe it's in honor of Halloween. It's a skeleton playing the guitar, wearing an astronaut costume. Yeah. So you just never know.
Never know with this crew around here.
Work here, huh?
So that's 3 places to the right. So 1, 2, 3.
So this is the classroom. Risco's, all the employees' kids are here. Distance learning, social distanced and everything. Very cool.
We wanted to take a minute. Thank you guys for taking the tour of Risco Incorporated. We thoroughly enjoyed showing you guys the process of manufacturing that we do.
It's always funner when you're actually here, though. But we got to do what we got to do.
Have a good one.
Have a good day.